Picture the final lap of a high-speed racing simulator. You're drifting around a hairpin turn, fighting for first place, and you're controlling the entire car by aggressively tilting a piece of fruit. This scenario is documented in detail within Sony patent US 2021-003110A1, a multi-billion-dollar corporation famous for engineering complex electronic consoles is actively researching how to replace their own expensive hardware with a literal banana. Take a look at the standard DualShock controller. It's a dense brick of engineered plastic, packed with delicate joysticks, triggers, and internal circuit boards. That density creates friction. A new controller costs $70 and requires a constantly charged battery. When a friend comes over to join a multiplayer game, you immediately hit a wall. If you don't have a spare piece of plastic, or if that spare happens to be dead, they cannot play. Sony's goal is to bypass the electronics entirely. By shifting the workload to software, they can turn a mug, a pen, or a piece of fruit into a functioning input device on demand. Historically, motion control has relied on active peripherals, like these PlayStation Move wands with their brightly glowing spheres emitting clear tracking signals to a camera. A banana is what the patent calls a passive, non-luminous object. It emits zero data. To see it, the system uses a machine vision pipeline that starts with color filtering. The camera scans the room and dynamically strips away all pixel data that doesn't match the specific yellow profile of the target object. Once isolated, the software performs contour mapping. It mathematically traces the physical boundary of that remaining color to define the object's exact two-dimensional shape. But holding an object means your hands get in the way, hiding parts of the shape. The system solves this occlusion by tracking the visible contours and automatically bridging the invisible gaps to complete the geometry. Through this filtering and tracing loop, the console stops seeing a piece of fruit and starts registering a solid, trackable digital controller. Tracking a flat two-dimensional shape is only half the process. The system then applies six-dimensional pose estimation, mapping the object's exact position and orientation across the X, Y, and Z axes. That spatial map translates physical motion into specific game commands. Tilting the object handles the steering, while physically pushing it forward along the Z-axis registers as pressing the gas pedal. You can even grab two objects, say two oranges, one in each hand. The camera detects the center points of both, draws an invisible line between them, and lets you rotate that line to simulate a two-handed steering wheel. The patent goes further by outlining a virtual interface. Look at this projection. If you wear a headset or look through a screen, the system overlays glowing augmented reality buttons onto the object's surface. Finger detection algorithms track exactly when your hand intersects those virtual coordinates. By calculating exactly where your thumb rests on the peel, the software treats any inert surface area in your kitchen as an interactive touchscreen. Processing this much visual data used to cause massive input lag, but modern console processors are capable of running these machine learning classifiers in real time without dropping frames. We've seen hardware companies experiment with DIY gaming before, like the precise cardboard engineering required to build this Nintendo Labo kit. Sony's software approach requires no physical construction. The engineering is completely digital. And while camera arrays like the multi-lens setup on this Xbox Kinect tried to map the user's entire body, they often struggled with fine motor skins. Sony's method focuses the tracking on a single object, providing the tactile feedback that empty hand gestures lack. Training software to understand the mundane objects we already own is more scalable than forcing players to buy specialized physical peripherals that eventually become obsolete. Look at the scale of PlayStation's corporate branding. It suggests that this patent establishes a technical foundation for Sony's future AR and VR ecosystems. By using neural networks to assign value to mundane objects, the system codifies a behavior humans have always practiced, taking a random tool and treating it as a prop for play. If this technology succeeds, specialized gaming hardware may recede into the background, letting the physical space around the player act as the controller itself.